I really cannot imagine where my research would be without 3D printers. I would really like to have a 3D printer at my desk. We don't currently have any of the existing low-cost machines because the part quality, resolution, and repeatability is nowhere where we need it to be.
In architecture and many design fields, the software tools have advanced pretty significantly, but there's been a gap between what you can actually design and what you can actually make. And I think the Formlabs printer provides an exciting opportunity to be able to design and then physically make quickly precise, complex geometry.
Formlabs changes the way people design things. They're going to be able to get really pro-quality 3D printed parts way cheaper, way faster than they've ever been able to do that before. Formlabs takes us a giant step closer to the engineer's dream, which is routine 3D printing, the way they'd print on paper.
To design a 3D printer that produces great parts every time, you've got to bring together a team of designers, engineers, and material scientists to make a tightly integrated product. If you can do that, you can fundamentally change 3D printing, and I think we've done exactly that.
Stereolithography is great. It's a tried and true process. It's been around for well over 25 years. It produces the best quality parts in the industry.
The way it works is pretty simple. A laser beam is drawn across the surface of a liquid plastic resin that hardens when exposed to a specific wavelength of light. After the layer is drawn, the build platform lifts and the process is repeated layer by layer until the part is finished.
We have a great user experience. We have powerful and easy to use software. We've built a reliable and beautifully designed printer, and we're developing materials which will enable our users to make amazing things.
The printer bot is a 3D printer. What's a 3D printer? 3D printers take ABS filament. This is the stuff that Lego's made out of. And it heats it up in this hot end and it puts it down on this hotbed. And it lays it down a line at a time until you've got a full layer. And then it moves up and prints another layer. Now after layer upon layer upon layer, you've got a part that you can hold in your hand made out of plastic. And they're very, very durable. So it's amazing to be able to design your own parts, and something that you just think of, you can design it in Google SketchUp. It's a free program. And you can put it into the machine here and it will print out a three-dimensional part. You can make all kinds of things. People are making toys, things that have utility, hooks, all sorts of designs. And these designs, if you don't want to design them yourself, they're available online at thingiverse.com. So it's this crazy new world where you can think something and then print it and hold it in your hand. Now, these 3D printers have been around for a while, and they're amazing. This is a Prussia Mendel. But I see a couple of problems with these printers. To get to widespread adoption, where there's one in every home, there's one in every school, kids are putting them together. A kid is probably not going to put together a Prussia Mendel. If he does, he's a smart kid. But these printer bots really address a couple of problems that I see with the printers that are out there today. One is the build time. That Prussia Mendel, it took me, hours and hours to put that thing together. And this went together in 45 minutes. Literally, the parts, you'll get them in a box, you'll take them out, you'll follow the online video, and you'll have this thing together in under an hour. You'll be printing in under 2 hours. After you get it together, you'll hook up the electronics, download the software, it's all free online, and you'll be able to print these three-dimensional parts. 3D printing, I believe, is going to change the world. If you can imagine not having to go out and get these small little parts, or something breaks, you'll be able to fix it. All the shipping that goes into moving parts from China over to here. So being able to design and make your own parts, imagine what that will mean for kids, what they think they'll be able to build, the ideas they'll have on improving something, they'll be able to see that right in front of their eyes in a very short order time.
Hello Kickstarter, we'd like to introduce you to the Rigibot 3D printer. I'm Michael and this is Randall, and we've created a customizable 3D printer that is easy to use and affordable for all. With this 3D printer, there's no limit to your creativity, and we'd like to show you why.
The standard Rigibot comes with a 10 by 10 by 10 inch build volume. The Rigibot Big comes with a mind-blowing 12 by 16 by 10 inch build volume. The Rigibot gets its name from its steel frame and high-quality injection molded parts. It can print both PLA and ABS materials. However, with ABS, it is common to get some warpage and cracking. For this reason, we recommend PLA. Using the same plastic components and longer rods and belts, the Rigibot can be customized to any size. Our company provides industrial 3D printing services using machines that can cost as much as $500,000. These machines could eat the Rigibot for breakfast. However, at 1/1000th of the cost, you will be amazed at what it can produce. The Rigibot is perfect for your home, office, and even school classroom. At Inventapart, we are committed to encouraging and helping kids get excited about 3D printing technology. You can purchase your 3D printer fully assembled or in kit form. For the do-it-yourselfers, we will have fully detailed assembly and operation instruction videos on our website.
Boxy is a desktop makerspace, bringing the power of a 1¼ horsepower CNC mill, a laser cutter, and a 3D printer as an all-in-one machine. Each tool exists as a rapid change attachment, providing the user the ability to switch from mill to laser to 3D printer in just moments. Our vision is to break the barriers for makers by equipping them with the creative power of a personal machine shop that is small, affordable, and easy to use. While immersed in the thriving startup ecosystem of Pittsburgh, my brother and I discovered the need for Boxy. Here we joined a rich maker scene and gained access to the specialized manufacturing tools accessible through Fab Labs and makerspaces like Tech Shop. We were inspired by the powerful new tools and access to manufacturing level machines offered by makerspaces, and we wanted more. So we focused our attention on creating a series of high quality desktop tools that embody the precision and the features that were once only accessible to large companies, with the purpose of making those machines available at the price makers, inventors, students, and designers can afford. And thus, Boxy was born. Boxy has the precision and reliability of a professional machine, with an industry-leading movement resolution of 4 microns. We sourced industrial ball screws, manufactured all aluminum components, and added stainless steel hardware, and then assembled them into an all-aluminum anodized body, creating the sturdiest, most accurate machine on the market, and one accessible to the average maker. Boxy can shape most materials you can source, from plastics to hardwoods to metals. Boxy is a true personal makerspace, allowing creators to move rapidly through design iterations and empowering small businesses to produce individualized products for customers. Boxy gives fabricators the ability to fuse methods, switching rapidly from 3D printing to CNC milling to laser cutting the very same component. To accomplish this, we designed Boxy to integrate all 3 tools into one clean, easy-to-use interface. Boxy is precise, durable, and reliable, and so easy to use that fresh makers can create complex components. With Boxy, we've decoupled professional, quality creation from location and decentralized the power of precision manufacturing. Boxy is a mobile machine shop, a desktop